Welcome to the PARC Forum. I'm Ann Balsamo. I'm a member of RED, the Research and Experimental Documents group here, and I'm coordinating the forum on behalf of RED until the end of January. I just want to remind everyone that there's no forum next week because it's Thanksgiving holiday. And on November 29th, the forum speaker will be Dr. Kate Hales from the Science and Literature program at UCLA, and I don't have a title for her talk yet. Today's speaker is Kevin Kelly, and Kevin is currently editor-at-large at Wired magazine and the author of two books that I'm familiar with, one called Out of Control, The New Biology of Machines, Social Systems, and the Economic World, which was published in 1994, and a second book called New Rules for the New Economy, 10 Ways the Network Economy is Changing Everything, and that was published in 1998. I'm familiar with Kevin's work kind of in my former life as a media theorist and a cultural studies person, and I understood among my colleagues that Kevin is often referred to as a kind of founding architecture of a new cultural paradigm that is sometimes goes by the name of the California ideology. Did you know that you're part of that group? The California mafioso that is sometimes also referred to. But I think the founding kind of rules of this new paradigm is to search for a way to build a value-based framework for assessing and apprehending kind of the consequences of technology, but also the creative possibilities of technology. And so it's the creative possibilities and the libertarian possibilities of technology that I think Kevin's work is most contributive to. His role kind of in developing this paradigm certainly began with his work at the Whole Earth Review, and I dug out the Signals, Communication Tools for the Information Age book that was published in 1988 that certainly made evident the way in which he was trying to think about emergent technologies in a kind of creative way. But I also understand that this kind of paradigm and this kind of framework continues to be kind of developed in his current work, and he told me about two additional projects other than the one you're going to hear about today. One is called the All Species Inventory, which I love is, it's a collaborative project, a massively distributed kind of work of information, kind of archival and information documentation and so on, that has as its goal to give every species its own web page. Is that right? Which I love that idea. He also has a second project that I had known a little bit about, which is the Rosetta Disk, which is another kind of massive distributed kind of archiving project to document all the known languages that are in kind of in use today. And he's got another project that he's going to talk about today, and the title of the talk is called The Self-Replicating Omega Library. And it too, I think, is kind of part of this whole kind of body of work that's been going on for a while. So please join me in welcoming Kevin Kelly.
Thank you. It's a tremendous pleasure to be here. I actually don't live very far away. I live up the coast in Pacifica. I should come here more often because every time I do, I have a great day. I learn lots. And I'm here actually to learn as well right now. I actually came and spoke about 4 years ago at one of your forums, and I had, at that time, a couple ideas that I was trying out, and I'm going to extend that initial experiment a little bit more this afternoon. I'm interested in a question that this next hour I want to, in some ways, follow through to its sort of absurd conclusion. And that is, what happens after we have digitized and linked up all the books in the library? And the reason why I'm asking that question is because I believe that, in fact, we're going to do that very, very quickly, that it's going to be something that's going to happen, that's part of it, I think, within our lifetime. And I'm interested in what happens after that. Where do we go after we do that? And what happens with what we do after we do that? What happens with when we have a library like this? What do we use it for? What does it mean? What does it give us? And I think my initial exploration is I came up with two things that this leads to. One's a seed and one's a mind. And I wanted to run those out, those two ideas. I want to begin with John von Neumann, who very early on in the history of computing came up with this idea of a self-replicating program. The idea that you could write a program that could contain within itself all the instructions necessary to reconstruct itself. And he was sometimes pointed to as kind of the first A-life experiment. After that, many years later, when computers became more common, I should say that von Neumann did his entire thing with pencil and paper and graph paper, trying to imagine this thing. When personal computers became a little bit more common, Chris Langton actually made a little tiny self-replicating program called a loop, which would generate visually and graphically more of themselves in an everlasting replication process. And so these things would sort of breed like cells. So there's an idea of a program, of a code that would self-replicate itself. There are other, and people naturally extended this idea to other things. There was a famous NASA project where they were trying to make a self-replicating lunar factory station. So it's basically, it's a station that could create all the ingredients necessary to make another one just like it. So you have a whole bunch of mechanical systems that together as a unit was acting sort of like a cell or a program replicating another, so out of that could come another lunar type station. And the idea was that you could maybe even envision this going across through the galaxies, one station making another station and sending it off. During the Second World War, there was a prisoner of war camp with some Americans in a prisoner of war camp, and they tried to do another kind of a self-replicating unit, which was they wanted to make tools. But they didn't have anything to make the tools, and so they, oh, I am sorry. Thank you. So the idea was that you'd make a foundry out of found materials. Now the foundry, you'd make some kind of tool, and that tool would allow you to make other tools, and out of that you could build a whole set of mechanical industrial processes. There actually exists a set of books by a guy named David Gingerly, who tells you how to do this. And the idea is that you make a backyard foundry, which is, these are some pictures of that. And then from the foundry, you actually cast the stuff necessary to make a lathe. And from the lathe, you make a mill machine and drill presses, and you could go on from there. So there's a whole system to bootstrap, basically, anything we could imagine from a very small set of initial ingredients. And so I've taken this general notion of trying to imagine this self-replicating system. And the question I began to ask myself is, I wanted a book that would tell you how to make itself. Okay, there's a document that would contain within itself everything to tell you about not just its content, but the vehicle, the medium. Okay, so this is a set of instructions that contains within itself all the information that you would need to replicate it and to go on from there. So I began looking around. First of all, I couldn't find this book. I thought, well, maybe this book exists somewhere. It seemed like a natural thing. But so it doesn't. But you could kind of put together one like this. And so the way you do it is that you find the plants that have fibers sufficiently long and pliable, like hemp, and you gather them up, and then you go through this process of beating them, soaking them in, peeling off the fibrous, the outer bark, soaking them in water, stirring them up, certain kind of chemicals to keep them suspended. You make a screen, and you float them off, and you get sheets, and you press the water out. And then, this is just the beginning, because there's obviously other parts. You actually have to make the type, make ink, rub the ink on the type, make a press, start and print, and make a book. Now, that's the general notion of it. To be specific, and there's various ways to make this book. The first way would be to just kind of describe what I'm saying, and then produce a little book, go to kind of a quick print-on-demand book and make a little book that would have all this information in it. But that's just kind of a first order approximation to the first order, because in fact the book is not produced exactly the same way as I'm describing it in here. So ideally the real book done this way would be a book that was made in exactly the same way as described. Okay, so I can make a first approximation by taking this material and putting it out in a book, but that doesn't really count. What we want is a book that's actually made by gathering up the fibers and making it. And so I call this idea the forever book. It's a forever book because the idea is that once you have the book, it can therefore, but with any human as an intermediate, replicate itself. You can give that book to someone else and they could take it and learn how to make another book just like it and pass it on. I was even imagining, in some ways, the idea of forever book clubs. And these are clubs of people who are really into this idea, because everybody would have a slightly different way of doing it, a slightly different slice of the kind of information that was necessary. And the idea that the only way you can be part of this club is if you had a success to the second generation. In other words, you have to make a book that someone else can take and successfully make a book and give to someone else. Then you can qualify for this club. That's the proof necessary, is it has to go to the next second generation. Okay? So someone else has to be able to take your book and actually go through the process and come up with another book just by following its instructions. So one way to start thinking about this idea of this self-replicating forever book is to think of it in another terms, which is to say, well, as I said, there's all different ways. There's hundreds of different ways you can make this in terms of the kind of content, the degree of detail that you want to give, the specifics. And that's, I think, some of the beauty of it. Everybody would have their own version of it. But there's also one version of it, which is what is the smallest set of instructions? What's the smallest amount? What's the shortest amount of material that you could give that would allow it to be replicated in terms of not just the content, but the media itself. And at the same time, I thought, well, another way you could ask this is, well, what's the most amount of material that you could self-replicate? What's the most content? So I began to think about a library that was self-replicating. So here's a library, and the library would contain within itself all the information that maybe wasn't just, that would deliver the stuff in the library, because the library might be more complicated than the book. It might include microfilm. It might include all the other kinds of things we find in the library today. So containing all that kind of information would get quite complicated, because you have to give enough information to a person or a set of people to actually recreate a computer or the web. That's starting to sound very, very complicated. It's not easily done. And in fact, the Forever Library starts to drift into something where it's not just a single item or unit. It's actually quite large. The kind of the end result is something closer, I think, to something that we might think of as civilization. I mean, that whole society. So you're trying to find out a set of instructions that can self-replicate itself as all that we know. In other words, if we were to say, okay, if we had to recreate our society as it is right now, we want a set of instructions, a library of all that information that, like the prisoners of war, that we could recreate and bootstrap. And so that becomes an interesting problem, I think, is what is that set of information that in the library that we would use? Now, That's what I call the Forever Universal Library. It's a set of instructions that can replicate fully all that we know. And what's interesting about that is that there's a couple of interesting things about that. There's one idea that actually replicating that library or going through that library may actually be a very interesting way of having education. Is you're actually recapitulating in some ways the origin of our society, going through that process of how would you recreate this? What is the structure of what we know? So there's lots of things that we don't know about our own culture that this actually would force us to examine. One of the interesting things about this is I think that if you thought the web was this library, I think you're wrong. I think you cannot find on the web sufficient information and context to actually make this library. This is my guess. I can't prove that, but my suspicion from just sort of looking around and researching is that the web right now does not contain all the information necessary to do this forever library, universal library. Because a lot of it is just sort of explicit, implicit knowledge that hasn't actually been written down. There's lots of reasons. But I think a lot of it is technical knowledge that necessarily hasn't gotten to the web. And some of it's just something people haven't thought about as necessary to even write down. So I think there's sort of a hierarchy of things. There's at the bottom is sort of we think of this as a library. Then there's a universal library, which is all the documents of the world. Then there's a forever library, which is this idea that you have sufficient information to replicate the library as itself. There's the forever universal library, which is all the documents in the world and that contain all the information necessary to make that replication. And then there's the Omega library, which I will talk about a little bit later. The Omega library is basically, it's all the knowledge of the civilization capable of replicating itself. It's all the information that a civilization would need to replicate itself in the same way that von Neumann machine would replicate itself. What's interesting about this self-replicating library is that it's a compression. It has the same relation to civilization as an acorn does to a tree, in the sense that it's a finite, small bounded amount of material that can actually expand into and unfold into something very, very large. And so at first it doesn't seem possible. At first you would say, well, we can't take everything about our civilization and reduce it down into a library. There's stuff missing. And in a certain sense that's right, but in another way it's not correct. In the same sense that if you do, can you imagine, is the oak tree, is it being compressed into an acorn? I mean, what do you lose? Where does it go? Where's all the stuff about the oak tree that we see as an oak tree? When it becomes into an acorn, we don't at first imagine it's even possible, but there it does. It happens all the time, almost every year. And so we all know about compression and how things can be compressed, but there's also a sense in which an essence is captured or not. And I think that we can imagine this set of information and knowledge as in some ways a seed that's capable of expanding. And in some ways it's like the seed in some ways contains an empty oak tree. It's an oak tree that has yet to be manifested, yet to have any kind of experience, but it's a tree nonetheless that has a frame that can be in some ways captured and distilled into an acorn. And so of course we have the same thing with humans. It seems remarkable to us that we can get all of us into something so tiny as a sperm. Now it doesn't capture everything of Einstein. A lot of it came from the culture, but nonetheless there is a huge amount that can be, at least biologically, compressed to a very small amount of code. Yeah, And the mother. As I said, and the culture itself. And that's actually a very important point, that the unfolding of this doesn't happen in a vacuum. The unfolding has to happen, there has to be an apparatus for this thing to unfold. Okay, and that's actually a very critical part of it. So what I'm imagining is a seed that can contain a society, a civilization. And that set of material, whatever it is the self-replicating omega. And it can be very small. And if we can imagine, like lots of everything else, the actual space that can contain a bunch of information is continually shrinking, it's entirely feasible to imagine that being in a very small space. I don't know how big it has to be, but it may be a lot smaller than we can even imagine right now. It doesn't have to be very big. So that's one line of thought. Okay, we can imagine this becoming some kind of a seed. What else could happen when we have all the books in the library? Well, there's another direction. What's going on right now is that everybody is actively and warmly and very truthfully trying to digitize every document, which I think is what we sort of expect needs to be done. We want to do that in every language, of course. And we would also like to do it for anything that's ever been written. That's sort of a pretty basic thing. Seems like a good idea to do that. That's basically what we would call the Universal Library. And that picture up there is the new Library of Alexandria, now being constructed, very empty of books, but it captured the idea of the first library in Alexandria, which claimed at the time to have most of the books written or known. A very small number compared to now, but nonetheless, the idea that you have everything, all documents. In fact, there is a program right now to digitize the cuneiform text of everything ever written. So, at first, that's a logical. This is a very logical idea to take all text and digitize them. What you want next, and what we're doing, is we have an index to all those texts. That's another very logical step. Then we have links between the text. And that's what we have with the web. We're linking every text to all other texts. And again, I think that's going on, and we will continue to do that as we digitize more and more things. We'll start to link them all. But that's not the end of it. I think there's other things that are going to go on beyond that. The next step, as I see it, is that we have link between the ideas within the text, so that basically every concept, every word, and every text is linked to everything else. And at this point, that sounds like a completely fantastical, impossible job to imagine everything ever written or recorded, to have every concept in that linked to all the other concepts. But that's what we do after we have everything digitized and linked. And of course, then we have an index to all the ideas. We have some structure to all those ideas and every concepts, terms, subjects, into everything that's ever been recorded or put down. Ted Nelson was kind of a lone voice in the wilderness for many years with this idea of a hypertext. He was a very early proponent, along with Vannevar Bush and others, of imagining linking things together. And at the time he was talking, very few people were listening. I happened to hear him very early. I sat next to him once, and he gave me this very long and involved, fantastic description of what was going to happen when everything was linked together. And you can see his documents in book form. He had a self-published book called Literary Machines, where he describes things like bookmarks and other aspects of the web very early. But what's interesting about that is that you can read the book up and down, and there's no hint at all of eBay in it. Because eBay is basically what happened, or one of the most powerful things that happen when you have hypertext linking. So what I'm suggesting is that the effects of this are not literary, or I should say not only literary, in the sense that they're social, they're commercial, there are identity, there's all kinds of things and ways this shifts by having all things linked together, all text linked together. And when we start to have all ideas linked together, other strange things begin to happen. Eugene Garfield was a guy, again, he was a former librarian who worked without much fanfare in Philadelphia. He invented the Science Citation Index, which is basically a way of, it's when you have an article and you have a citation, it's like saying, well, give me all the other articles that have cited this paper. It's a way of backtracking through links. It's a way of hypertext linking before the web. It was seen as a scientific tool. But the idea, again, was that he was linking ideas very early. And if we extend this idea, what I think you're able to do when you have all ideas linked to each other is that you're able to actually retrace an idea back to its origin, and therefore also, in some ways, forecast the idea's trajectory. I want to say something very controversial, and that is that in the West right now we have I guess a hesitation about the kind of Victorian idea of discovery. You would talk about a gorilla being discovered in 1847, when it was very obvious that many humans had encountered this before. And we could talk about Portola discovering the Bay Area when obviously many indigenous tribes have lived there for thousands of years. And so in what way were these discovered? And in one way, it's a very chauvinistic Western viewpoint to imagine that. But at the same time, I think there's actually some way in which this is valid. And that is that what these discoveries mean is that they are linking this knowledge to a vast, established body of knowledge that is commonly held by many, many people and is growing in a kind of a structured way. Lots of the knowledge about the Bay, say, was held by very small groups and not shared because of language problems and geographical isolation. So the discovery of the Bay Area, in one sense, was when you took knowledge of the Bay Area and brought it into the larger scientific worldview, the larger network of knowledge that had a record that was connected and linked to each other. The discovery of the gorilla, even though the gorillas had been known by humans, was basically linking the idea and the nature and the description of the gorilla to the web, basically. Not the web that we have now, but the web of knowledge that existed then. So this idea of linking things in is very important, because I think that what happens is that unless things are linked, they're not really known. And what we're trying to do is, what we're doing with this right now is, we're taking these ideas that exist, that have communities at times, that have integrity and context, and we're trying to link these ideas into the greater corpus, the greater library of knowledge. I think ideas that are not related to other ideas are not basically known. They're known within that community, they have value and context. In fact, that's often a problem, because sometimes ideas that are trying to move out of one small context into another context don't go very easily, because all ideas are linked to each other, and you can't kind of just move one part without moving the whole thing. It becomes very, very complicated. And that's why there's a problem oftentimes in incorporating, say, some tribe's knowledge about dream world, how they view the world. Ideas don't move easily linked to our body of web knowledge because they don't go by themselves. They have to take the whole thing or nothing. So we're in the process right now of trying to bring together and connect up all these ideas into this library. So after we do all these texts, after we do all these documents, we're doing every movie. We're doing every TV show, every radio program, every photograph, every telephone call. All communication is being collected. And eventually, I believe, every object as well. Every object, well, not just the information about the object, but the objects themselves, it will have embedded processing. They themselves will become a document, so to speak. They themselves will become a node in this library. How big is this? Well, there was a great paper by Hal Varian and Peter Lyman at Berkeley asking how much information is there in the world right now? If we take all this stuff that I just went through, how much information is there? And they calculated that there was 1.5 exabyte, and exabyte is a billion gigabytes, which comes around 250 megabytes per person alive, which means on average, of course averages don't mean anything in terms of global population, but on average people are generating 250 megabytes of information. Okay? If we look at that, what's interesting about that, only 0.003% of it is printed documents in terms of bytes. So printed documents is a very small percentage of the total amount of information being stored, being generated and stored. Most of this library is going to be written by you. Okay, by that I mean is if you look at the most of the documents, most of the material is for very small audiences, for audience of one or audience of a couple, memos, email, reports, stuff like that, telephone calls. So this is a graph which shows the amount of documents on one axis, and the other one is the size of the audience. And so there's a few documents that have audiences of 1,000. That's called publishing. There are many thousands of documents or texts that have an audience of only one. There are, I think the last figure I heard was about 600 billion emails sent every day, in the US. So there are just a lot of these. There's 600 times more information generated for an audience of one than for publishing. And this is just an exponential chart of the total amount of volume of information. And what we can see from that is that, well, you can't read it very well, but again, stuff generated in the office's internal consumption is this huge, huge portion of this. But what's interesting, and this is Michael Lesk's observation, is that the storage capacity that we're generating and its cost has actually exceeded the human production of information rates in the last year. So last year, our ability to store this material has actually exceeded our ability to produce it, which means basically is that, and this is the cost of a gigabyte going down rapidly, is that we already have enough disk space to store everything we all could possibly say or write or photograph. So my message is that this idea of the universal library is sort of possible right now. We can do this. It's available. It's cost effective already to do this. And so I'm trying to say, well, what's going to happen after we do that? And I think Xillia Onyx is where we're headed. Xillia Onyx is the realm of zillions. It's when there are so many interacting parts that we're in a different realm. We're in a different phase. I define Xillia Onyx as approximately anything greater than 10 to the 10th, 10 billion. And when you get into domains that large, which is where we're getting with these documents, things behave differently. Something happens when you have 10 billion molecules, you sort of get cells. When you have 10 billion atoms, something happens. When you have 10 billion molecules, something happens. When you have 10 billion cells, you get these sort of you get interesting creatures that can do very, very different things. And what's interesting is that I think we're at these meta levels of organizations. So we have superorganisms based on smaller. I mean, you have units that are complicated. They become at 10 billion another complicated level. That right now we're headed towards, probably within this decade, 10 billion web pages. And of course, our own human population's headed toward 10 billion. I would suggest that we're going to see something happen as we get up into this realm of Xillia Onyx, just dealing with 10 billion web pages. And what's happened is that another aspect of this look at information right now is that most of the information right now is being generated not by humans, but by our machines. And in the same way that most of life is microbial, there's something like close to 40% or more of the biomass in the world being microbial in origin. It supports the higher cost animals who have higher energy costs in rarer numbers. In the same way that the flood of data flowing through this system and the flood of data in the library itself is not even going to be of human generation, but it will support, in some ways, the human communication. So I imagine kind of this food web, where you could actually start to generate texts, have them self-assemble from these microorganisms, these microtexts. So you have microtexts being assembled by various routines and subroutines, being rewarded for being useful, filtering up in a kind of machine-generated way. So a lot of the texts in this library are not even either being generated by humans or even being read by humans. Okay, and so most of us wouldn't necessarily sit down and read a book that way, but there are many examples in which a weather report or some kind of a traffic report might be, in a sense, being a document that's being generated by a machine, that in most cases not necessarily even being read by a human, but in some cases could be and would be very useful. That forms this sort of ecology of low-level text generation and consumption. And what's also interesting is that in very high space, when you get into Xillia Onyx, in a very high dimensional space, that the act of actually finding something at that point is actually almost equivalent to creating it. Okay, the steps to actually navigate through your way is almost in the same way as creating it, in the sense that that this document may not exist until you actually go to look for it, and the act of looking for it as you click along or as you navigate through is actually creating it at the same time. So, so what happens is that the distinction between creating and finding actually kind of goes away, and it becomes less important. So we have this idea of self-assembled books, self-assembled texts and documents in this very large library. And the one last thing that I wanted to sort of add to this is that there is a kind of a rough idea that even in human mind, that when we are perceiving something or when we're remembering something, we're actually re-perceiving it. That memory is actually a type of perception. So what I'm suggesting here is that while we think of this library as a static thing, what I'm saying is that when we have all these ideas linked to each other, that when you're teasing out and drawing out an idea, when you're going into the archive to get an idea that exists, it is as if we're perceiving that idea, not just remembering it. So it's an active perception. It's not just a semantic thing, but I believe that it is truly what's going on, that in a sufficiently large library, that the act of retrieving something is the same thing as perceiving it. So this leads me to this idea that I resisted for a long time because I find very sort of new agey, which is that we have this library becomes sort of a kind of a large-scale mind. And I'm not the first to come up with this idea. This is H.G. Wells, who wrote the book on the world brain, a very interesting document from earlier in the century. His idea of the world brain was not quite the same one that we have. It was more based on the French encyclopedias. He imagined a group of people generating this large body of knowledge that anybody could have access to, but it was being centralized. It came from experts. It came from authorities. And it was vetted and authorized. And now the kind of emerging idea that we have is we have this sort of membrane around the Earth that's composed of the neurons, the fiber optics and whatnot, and the library itself forming kind of a neuronic apparatus. And so we have books like The Global Brain and The Global Brain Awakens, all of which gives me kind of creeps. But I'm forced to kind of take the idea seriously in some capacity, not that I believe that there's going to really be a brain, but in the sense that I think that making this library and linking things up is not just a literary library-like action. I believe that it's much more powerful than that it suggests other ways to view what's going on than the mere archiving of our knowledge, that in fact it is a matrix for something very, very active. So we have a seed and a mind. And I think what I'm suggesting, again, is that these metaphors may be useful. As we try and decide what it is that we're doing, I think we should think about what comes after linking everything up. What happens when we have everything linked up? I think what happens is that just like things like eBay popped out of hypertexting, I think that when we have every idea linked to every other idea, when it has structured, when we add that kind of structuring over time, that this is an extremely subversive, extremely powerful and potent matrix that will produce a very powerful tool that we haven't had before. And I think the idea of imagining compressing this into a seed, having this broaden into a mind are useful metaphors, and that the idea of actually combining the two, so you have a seed and a mind, that's kind of scary because you have this little thing that's self-replicating, and yet at the same time maybe sufficiently endowed with our own intelligence that it can actually learn, which is a tremendously useful thing to have. I call that the self-replicating omega library. It seems to me that that's where we're doing. That's where we're headed. If nothing else changes, we're going to digitize everything. We're going to link everything. We're going to link every idea. We're going to take every action and every communication that we have and bring it into this larger network of interactions. And that, even winnowed down, would be able to contain within itself sufficient knowledge to replicate. I have no idea if we'll do that, but that seems like where we're headed. So I want to thank you for your attention.